Welcome back. In our last lecture, we covered the standard numeric types, integers and floating point numbers. Today, we're going to explore some of Python's more specialized numeric types and representations, complex numbers, and the use of binary and hexadecimal formats. One, complex numbers. Complex. A complex number is a number that comprises a real part and an imaginary part. In mathematics, the imaginary part is represented by I. In Python, we use j to denote the imaginary part. Here, 5 is the real part and 3j is the imaginary part. Python uses the complex data type to store and perform mathematical operations on these numbers, which is particularly useful in electrical engineering and scientific computing. 2. Binary, octal, and hexadecimal representations. While Python stores all numbers internally in binary, base 2, we usually work with them in decimal, base 10. However, Python allows us to represent numbers using other bases directly in our code. This is common when dealing with low-level systems, security, and memory addresses. Binary representation, base 2. To write a number in binary format, we prefix the digits with 0b. The number 0b1010 is interpreted by Python as the decimal number 10. The 0b simply tells Python how to read the digits that follow. Hexadecimal representation, base 16. To write a number in hexadecimal format, we prefix the digits with 0x. Hexadecimal uses digits 0 to 9 and letters A to F to represent values up to 15. The number 0xa is also interpreted as the decimal number 10. Note that Python also supports octal base 8 using the 0 prefix, but it is much less common than binary and hex. We go to built-in conversion functions. Python provides simple functions to convert between these formats. The bin function returns the binary string representation. The hex function returns the hexadecimal string representation. The int function can convert a string in any base back to a decimal integer. To summarize, Python handles specialized numbers like complex using j. For low-level representation, you can use the 0b prefix for binary and 0x for hexadecimal. Now that we've finished with the numeric types, we move on to one of the simplest yet most vital data types for programming logic, the Boolean type. I'll see you in lecture 3.4.